Hey guys and gals, today we're going to be looking at absorption and emission spectrum. And what this comes from is an discovery in the 1860s that every different type of element gave off its own different colors of light in something we call an emission spectrum. So it was known since the days of Isaac Newton that if you pass white light through a prism, you can separate it into all the different colors of a rainbow. When this was tried with various elements, what we found is that instead of the full spectrum of colors in the rainbow, instead you only saw a very few colors from each individual type of atom, and that each atom gave off a different series of colors, if you will. And these different series of colors that were given off were called emission spectrum. And then if you pass light through a series of atoms, say you have a gas and a tube and you pass white light through it, it would absorb just certain colors of light. And Bohr was the guy who reconciled this with what's actually going on inside of an atom. By this time it was realized that different colors of light contain different amounts of energy. So for instance, colors closer to purple have more energy, colors closer to red have less energy. So a beam of light that is red in color is going to have less energy than a beam of light that is purple. And Bohr showed that these emission and absorption spectra could be explained by the behavior of the electrons. And so let's take a look at this. Here we can see that the electron is in the first energy level. And what we're going to do is we're going to shine a beam of light on this, and if that beam of light is just the right color, that is, it contains just the right amount of energy, the electron can jump from the first energy level to the second energy level. So let's take a look at what that looks like. So the light came in, was absorbed by the electron, and the electron jumped to a higher energy level. And with different colors, here you can see blue is the color, the amount of energy needed to jump it from one level to the other. And now look up here at this absorption spectra. Notice that there are lines missing from this. And this is the absorption spectra for this atom. And what happens is we see that this particular type of light, this ultraviolet light, gets absorbed. So if we were to shine the full spectrum of colors on this, that this particular light wouldn't show up because that light would be absorbed by the electrons. Same thing, there's a line for blue that's missing right here. That blue light was absorbed, causing the electron to move from a lower energy level to a higher energy level. And we can jump this up. We'll go up to the fourth energy level. And here you can see that that was infrared, but sadly won't show up on our absorption spectra because it was not much energy involved there. So now what we can do is we can cause this electron to fall from a higher energy level to a lower energy level. And when that happens, it's going to give off energy, and that energy is given off in the form of light. And this is where the emission spectrum for an atom comes from. When the electron falls from a higher energy level to a lower energy level, it gives off light. And the particular color of light can actually tell us how much energy is lost in going from one energy level to the other, and from this we can actually get a measurement of how far apart the energy levels are in an atom. So just by looking at the light that comes off of it, we know how far apart all of these are. So let's look at going from the fourth energy level to the second, and you can see that gave off ultraviolet light. And now let's jump back to the first one, and there you can see the light that has been given off and as these two bars on the emission spectrum. So that's a particular frequency or color or energy of light given off by the atom. So to sum up, if an atom goes from a lower energy, or an electron rather, goes from a lower energy level to a higher energy level, it's absorbing some color of light, and so we'll see that as a black bar on the absorption spectrum. And then when it falls back down, it gives off certain colors of light depending on the distance between the energy levels, and we see that in the emission spectrum.